Hi everyone, welcome to the Chemistry Learning channel. I'm very excited to share with you my passion of chemistry and I hope you'll enjoy this video. In this video, I'll be talking about what is mass percent composition, empirical formula, and the molecular formula, and I'll be working one main example. In this slide, we'll see what is the empirical formula and molecular formulas. Empirical formula is the simplest ratio of elements. It shows the simplest whole number ratio of atoms in a compound. And then the molecular formula is the exact number of atoms in a molecule. So in this example, we have H2O as the empirical formula and then H2O again as the molecular formula. This is because for water, it doesn't get simpler than H2O. We can't divide by another whole number. And then for O2, we have O2 as the molecular formula, and then the empirical formula is just oxygen. This is because O2 can be simplified if we divide it by 2. And then for empirical formula, we have P2O5, and then the molecular formula is P4O10. This is because we're able to multiply the empirical formula to get a more complex molecular formula. If we multiply the subscripts by 2, we get this. So 2 times 2 is 4, and then 2 times 5 is 10. So we're able to divide the molecular formulas by 2 to get this. However, this we cannot simplify any further, so this is our empirical formula. In this slide, I will be discussing what is mass percent. Mass percent is the percent of each element in a compound. This is very similar to the concept of a weighted average in math. In this equation, we have the mass percent is equal to N, which is the number of the element in the formula, multiplied by the atomic weight of the element, divided by the molecular weight of the entire molecule, multiplied by 100, which gives us the percent value. In the next slide, I will be calculating an example. In this slide, we will start calculating the mass percent of C2H5O5 ethanol, and we will be finding the mass percent of carbon, hydrogen, and oxygen. First, we'll start with the base formula. As we discussed in the previous slide, percent is equal to N, which is the number of atoms multiplied by the atomic weight of that element, divided by the molecular weight multiplied by 100. So first, in this example, we will be calculating MW, the molecular weight of C2H5OH. In this slide, we'll be calculating the molecular weight of ethanol. So ethanol has 2 carbons. It has 6 hydrogens because there's 5 here and then 1 on the end. And then it has 1 oxygen. So if we go to the periodic table, we can get the atomic weight for all of these elements. And if we plug it into the equation, we get 2 times carbon, which is 12.01, plus 6 times hydrogen, 6 times 1.08, which is 6.048, plus 1 times oxygen, which is 16, which is equal to 46.07 grams per mole. Using that information, first we will find the mass percent of carbon, which is equal to 2 because there are 2 carbon atoms multiplied by 12.01 grams per mole, which we got from the periodic table as we saw on the previous slide, divided by the molecular weight of ethanol, which is 46.07 grams per mole, and we calculated this on the previous slide as well. If we multiply that by 100, we get 52.14% for the mass percent of carbon. In this slide, we will find the mass percent of hydrogen. So using our base formula here, we have 6 hydrogens because we have 5 here, and then the subscript here is 1, so we have 6 total hydrogens. And as we found on the first slide, the atomic weight of hydrogen is 1.008 grams per mole. And then we found the molecular weight of ethanol on the first slide as well, which is 46.07 grams per mole. If we multiply that by 100, we get the mass percent, which is equal to 13.13%. In this slide, we will be finding the mass percent of oxygen. So in order to find that, we start with the same base formula. And since we have 1 oxygen in the formula, we put in 1 for N. And then we found the atomic weight from the periodic table of 16 grams per mole. And then we first calculated the molecular weight of ethanol, which we found to be 46.07 grams per mole. If we multiply this by 100, we get 34.73% for mass percent of oxygen. Overall, to sum up the concepts, we first start with the percent composition, which is usually close to 100%. And then, similar to the problem we just worked out, we'll determine the empirical formula using the percent composition because each element, as we found out, will come out to a certain percent, and that is the ratio we can use to determine the subscript for the formula. Using that formula, we can tune it down and find the molecular formula using the total mass of the compound. Because with the mass, we're able to scale the empirical formula into the molecular formula. Thank you for watching this video. I really hope you enjoyed it. If you liked it, subscribe, like, and share.